All right, something most of us use every day, either in our homes or at a laundromat or washing machine. So in a washing machine, you've got a motor to run the drum where the clothes are sitting. You have to be able to spin it, also to agitate it back and forth. So there's different motions. Now what you see here, if you've taken a course and learned a little bit about transistors, what you see here is a kind of like an H-bridge, except it's an H-bridge for a three-phase motor. So each of these transistors can drive current one way or the other through one of the three coils of the motor. And in doing that, in doing it in a certain sequence, can change the direction and the speed of the motor. So that would be your electronics, the mechatronics over here. And then the control for that is coming, again, this is a block diagram, so it's coming from this main controller down here. And you see where it says PWM, that stands for pulse width modulation, a term you might have run into in a course that you've already taken. So again, if you look around this, you see some sensors, a water temperature sensor. We've got, a Hall element, that would be associated with the motor. It's actually a magnetic sensor that senses the position of the motor. So there's another sensor. Then you've got a few different valves to run the water in, to drain the water out. A pump to pump the water in. And those are all controlled by triacs, which are they're kind of like transistors, except they're designed for either switching 100% on or 100% off. And they're used with AC type systems. So anyway, not to go into all the details, but you see you've got all the basic parts, moving parts, electronic controls, and a programmable controller that give you the function of a washing machine. Okay, next one, clothes dryer. Similar kind of thing. You've got heaters involved. Where's the main heater? Okay, here's, that looks like, so there's a drum that rotates. Here it is. Here's the main heater. It's just a big resistor. That's the same symbol as a resistor. Then you've got some temperature sensors. You got a moisture sensor. It's actually a much better way to determine when the clothes are dry by sensing the moisture of the air that's flowing out of the system rather than just putting on a time. If you do it as based on timing, when I was growing up, they didn't have the moisture sensors. So you just kind of made a guess. Okay, it's probably going to take about 40 minutes or whatever. But sometimes you wouldn't have enough time, and the clothes would be damp, and other times they'd be sitting there dry as a bone, running around and wasting a lot of energy. So there's an example of an electronic sensor that really saves a lot of energy and makes a system more efficient. So what else? We got things that check whether the door is closed, whether the motor is on, I guess, some relays. And so this is your main control board. And it doesn't really show where the controller is, but it would be on that main control board. Okay, so that'd be a block diagram of an electric dryer system. Okay, so that brings us to the Roomba, which some people have in their homes. It's a handy little device that automatically wanders around the room when you're not at home or at night. And it's smart enough to make a map of the room. It learns by traveling around the room where the obstacles are. It's set up so it automatically won't go falling down the stairs. It can sense what's called a cliff. So you can imagine all the sensors that are needed in a system like this. So this is the main display screen, the main user interface with all the indicators and the control buttons that the user is using. But behind the scenes, kind of under the hood, let's see. Okay, yeah. So here's, if you flip it upside down, you see a lot of the moving parts. So there's there's a little sweep. It's a little spinning brush that kind of kicks up the dust. And then there's the main vacuum system that's pulling the pulling the dirt up into the dust bag. Then there are wheels to control the motion, and there's also the thing about one of the really cool things about this is that it has a sensor that can tell whether the battery needs to be charged, and if it does, if it's getting too low, it finds its way automatically back to its own little charging port, and so those contacts are for the charging. So it's supposed to be a completely self-sufficient unit. And here are the cliff sensors on the side so it doesn't go toppling down the stairs. And then here's a block diagram. So once again, you've got mechanical moving parts, electronic controls. It seems, based on this, it seems like everything's built right onto one board. So the pulse width modulation to control the speed of the motor is coming right off that board. And so here's another thing. Now, whenever you have rotational motors, this is something else you might remember from a prior course, is encoders. It's a way of monitoring how fast and how far a motor has turned using an optical disc. So these both wheels have encoders, so the speed and the amount of distance the motor has run can be recorded. And that information is extremely useful and essential in creating this map that the Roomba makes of the room. So it knows exactly how far it's traveled. It knows whether it made a right turn of 20 degrees or 30 degrees. And so all that data is put back into the system to create that memory map. And then it allows it to know where to go in the room. And then you've got a bunch of sensors. A bump sensor can tell whether it hits a wall. Cliff sensors, as I mentioned before, if it hits like a stairs. Okay, I guess other wall sensors, a whole bunch of things like that. And then a battery running the whole thing. Okay, so that is the Roomba. And, okay, this one, oh, this wasn't on my list, but anyway, a DVD player. Again, another technology that's becoming gradually obsolete as more and more of this stuff is streamed online. But basically, for a DVD player, you have a spinning disc. Here's a disc motor and a sled to move the DVD into the machine and out. See, that's where you put the DVD in, you slide it in. So we've got motor drivers for the sled and the disc. And then we've got an optical system to read the ones and zeros off the surface of that disc and convert those into something that's an actual video signal. So moving parts, sensors, controller, SoC. It's another term for kind of like a central controller. It's called system on a chip. Just another term for a controller. Okay, and the last thing here I'm going to show you is the Quadrotor. So again, the key moving parts on a Quadrotor are the four propellers that need to be balanced in, well, the motors that drive them have to be very precisely controlled in order for the Quadrotor or drone to stay level, to be able to hover, to go up, down, or whatever the user wants it to do. So a huge part of this system is, where is it? There's, I'm just looking for it. Somewhere on this system is a, I think I have a name for it. Yeah, an IMU, inertial measurement unit. So what that is it measures whether the Quadrotor is tipped, whether it's accelerating up or down. So there's actually 6 things that it's sensing. It's sensing motion in the X direction, the Y direction, and the Z direction. That's X is kind of horizontal, Y is horizontal 90 degrees perpendicular, and then Z would be the vertical. So those 3. It also senses rotation around X, around Y, and around Z. So with those 6 numbers, it knows whether it's level, whether it's tipped, and based on where it is, it drives one or more of the motors faster or slower to correct its position or its orientation. So this is actually a very impressive mechatronic system with moving parts and sensors and a processor and a user interface. So these are all the different components you find in a quadrotor. You've got brushless motors to drive the propellers, electronic speed control for the brushless motors. That would involve pulse width modulation to control the speed. Also some kind of embedded microcontroller at the core of everything. And the IMU that I mentioned is sensing the orientation and position of the motor. So there's two aspects of it. Accelerometers are going to sense linear motion in X, Y, or Z, and the gyroscope is sensing rotational motion around the 3 axes. So 6 pieces of data. These quadrotors also have a built-in GPS, so they actually know where they are relative to where they started. And then a huge part of the system is the camera, because that's one of the main applications that people use drones for, is to take videos and pictures from up in the air. So the camera positioning system is a whole system on its own. And then you've got PID position control used to get this feedback from the IMU and correctly drive the motors. So that's another big piece of technology. So that gives you an idea of some different mechatronic systems that you might run into in everyday life. This is a drone that's been opened up and shows you some of the parts, where they actually are physically located. I'm not going to go into great detail on that, but there you go. There's a controller, the 4 motors, and the drivers. All right. So these examples are all everyday consumer items, but the same technologies are used in manufacturing and in engineering and all kinds of product development and those types of very sophisticated robotic systems,